皆さん、こんにちは。僕はミスタースーです。今日のビデオはポラの関数です。一緒に始めましょうよ。Alright, so polar equations, what are they? Very special way of defining points on a plane. So imagine that you're driving a car and you're going like to your friend's house or something. So here's where you start, here's where you end, but we're in a city, so there are buildings that you can hit. So you don't hit the buildings, you go in the road. Say you go this way, turn, go this way, then turn again, and then you got to turn again, and you kind of like get into their street, and then go around some houses, and then turn once more, and then there you are at their place. So what's special about these? These are basically directions defined with x and y coordinates, in a way. Basically, they're just all parts of a rectangle. So there's actually another name for x and y coordinates, which is just called rectangular coordinates, because you think of going up, down, side to side, and that's kind of what you would do in a rectangle as well. Well, imagine now that you're in an aircraft. Now you don't have to worry about hitting buildings, so you can actually just fly directly there. Okay, realistically, you're not going to fly an airplane, but like, let's just say if you could levitate, for example. So you start at the same starting point, your place, and you go to that place, which is your friend's place. And let's connect that better. That basically is a straight line going that way. So what information do we get from this? Well, we get a direction. A distance. So we see how far it is to just go there. And how do you get there? Well, you need to go a specific direction. So I'm going to call that theta because it's an angle. But this theta just tells us the direction of your trajectory. So to compare that and kind of just summarize, the information given by each of them is just, for rectangular, you're looking at left, right, up, and down. That's pretty much it. That's what positive, negative x, positive, negative y really means. And polar, you're given two pieces. You're given the direction, which we can call the angle. And then you're also given the distance. So how far are you from, in this case, we're talking about the origin actually. So this is going to be a radius. Alright, so using polar coordinates, trigger warning, emphasis on the trig, because we're using angles, so we're definitely going to be using a lot of trigonometry. Therefore, trigger warning. Anyway, so let's try to plot some points here. And that'll kind of give us an example of how these actually work and how they're different from x and y coordinates. So let's see, let's get 3 comma pi over 4. So 3 comma pi over 4, that's going to be, let's look at pi over 4. So if you know your unit circle, you're fine. If not, learn it. Pi over 4, and then a radius of 3. So starting from the origin, we're going to go 3 units on the pi over 4 axis area. So we have a point there. And you can kind of look at it as xy coordinates, but here it's obviously a lot easier to look at it that way. So now let's get 2 more, 5 comma 2 pi over 3 and negative 5 comma 2 pi over 3. If we look at those two, what we get is, well, we got to go to 2 pi over 3. So again, unit circle, you know where it is. And then it's got a radius of 5. So we go 5 on that axis and plot it right there. I'm going to color code these so that this is going to be in green and the other one's going to be in yellow. So this goes actually in the negative direction. So same angle, positive's that way, negative is that way. So we'll just go negative. So find 5 there, and then that's it. -5 comma 2 pi over 3. Again, you can find these all with xy coordinates, but in these cases, these ones in particular are a lot easier with polar. All right, so let's actually try it then. So graph this. Just like with parametric, the easiest way to start this is just plot points. And then you'll start to see the shape, and it'll start to make a lot more sense. So starting here, when we have 0, we get 5, because cosine of 0 is 1. And then at pi over 6, we get, let's see, square root of 3 over 2. That cancels, so we just get square root of 3, adding to 3. Similar thing here, I'm just going to start breezing through this. 3 plus square root of 2. And then this is going to be 3 plus 1, so that'll be 4. Yes? Yeah, because 1/2. And then the next one over there, we get 0 plus 3, so what we get is just 3. And then the rest of this, notice that I already have that filled out because I'm not going to just reason through literally all of this and waste time in the video. But also notice there's some nice stuff that goes on here. Notice the patterns. So there's a lot of repeating. The pi over 6s, they all basically have the same thing. It's just the signs are different depending on cosine. Pi over 4s, exact same type of pattern going on. Pi over 3s, again, same type of pattern going on. And if we go to the pi over 2s or the whole pi's, we get a very similar thing as well going on. Here we have those whole numbers, and they're odd. Something's happening there. Anyway, let's start plotting them then. So the first point is going to be at 0 radians, and it'll be a radius of 5. Next one, pi over 6 radians. So square root of 3 is approximately 1.7 if you want to just do it that way. So 3 plus 1.7 is about 4.7. So around there. Square root of 2 is 1.4-ish. So just to estimate, we got around, let's see, yeah, 4.4, more or less there. Then we get to 4. Then we get to 3. And then, yeah, I'm not going to plot the rest of them like that. Just do it yourself. Here they are. And then when you connect them, you get this. Okay. So as you can see, it's not too difficult. It's more of just tedious to graph these. All right, and then now same thing is going to happen here. Just going to graph that thing. I'm going to go through getting the points for 0 to pi over 2 with you, and then the rest of it's just there. Okay, sine of 0 is 0, so we just got 1. Got 1/2 plus 1/2 times 2 is 1. 1 plus 1 is 2. Square root of 2 over 2. 1 plus square root of 2. Okay, we've got square root of 3 over 2, so 1 plus square root of 3. Got 1, so 2 plus 3 is 2 plus 1 is 3, sorry. And the rest of them, look, same patterns. I'm not going to circle them and waste time, but basically look at them, got the same idea. Now let's plot this. So 0 radians, we got 1. And then at pi over 6, got 2. And then the rest of them, let's just keep plotting them. And remember, square root of 2 is about 1.4. Square root of 3 is about 1.7. That'll help with approximating these things. Okay, we get here, and yeah, that's the rest of them. And if you connect them, you get this. All right, so you get a bunch of interesting circular-looking graphs when you do polar. And it's not really difficult. It's just really, really tedious to do. So just keep at it. And know your trig. You gotta review your trig in order to get this.
ご覧いただきありがとうございました。このビデオを楽しめたといいねしてコメントして購読してください。次のビデオに会いましょうよ。